All right, so next topic we're going to talk about is enantiomeric excess. And so let's take a look at when we draw something, things, what do they mean? So when you draw this, right, there's a stereo center right here. This carbon is chiral. But when you draw it like this with no wedges or dashes, you're not indicating whether this is left or right-handed. And so when you draw a molecule like this, what you're saying is you have a mixture of the two enantiomers. So if you see a product like this is my product at the end of my reaction. That means that I'm going to have a mixture of the two. This is called a racemic mixture. And if you think about it, it's not going to be optically active if it's 50-50, right? The left hands are going to shift it to the right hands are going to shift to the left, or vice versa, but they're going to cancel each other out. So on the other hand, when you draw something like this, right, now I put this wedge on this alcohol. Now I am indicating that I have only one of my enantiomers. In this case, I'm only have the R enantiomer. And so this is also sometimes called as optically pure or enantiomerically pure. Another measure, what if you have a mixture but you have more of one than the other? We call this an enantiomeric excess. And it gets the symbol EE. And it's a measure of how much kind of one enantiomer you have versus the other. And so, for example, if you had something that was 25% R and 75% S, to find the enantiomeric excess, we take these numbers and we subtract them from one another, right? So we do 75 minus 25, that's 50. And so we say that this has a 50% enantiomeric excess. Vice versa, if you want to do the other way, right? If someone tells you it's 33% EES, right? What does that mean? It means that 30% is just S. So that means that we have a whole 70% remaining. Of that 70%, it's a 50-50 mixture, right? And so if you divide 75 by, or 70 divided by 2, that means that there's a whole nother 35% S. And so if something is 30% EE and S, it has 35% R and 65% S, right? If we add up the 30 and 35%, we get to 65%. So just understand enantiomeric excess, and all of this stuff is experimentally found. Through polarimetry, which is just basically looking at this compound through some pure polarized light and seeing how it bends the light. If you think about this excess stuff, any part of this 50-50 mixture will cancel out, and so it's just the excess that's going to rotate the light.